Hey there, freaking nerds. A lot of people are upset that FSR 4 is only supposedly going to work on RDNA 4. At least so far, AMD is saying that FSR 4 utilizes the new features in RDNA 4, like the FP8 acceleration, and they're talking about it being exclusive to RDNA 4. But I've heard a lot of rumors that apparently they're quote-unquote considering porting FSR 4 to RDNA 3. And what I think that really means is that they are planning on doing that. They just don't want to be obligated to do it. They want to reserve the right to potentially not release it if it doesn't turn out well. But yes, anyway, when I was reading these papers for my last video, talking about transformer style networks and how they can work within a CNN model, which was very relevant because of AMD confirming FSR 4 is a hybrid model, confirming in fact that it's a CNN transformer hybrid. Based on this notebook check article here, this one up here, AMD has apparently confirmed FSR 4 uses a proprietary model that takes the best of CNN and transformer models, according to the company. So that was my speculation based on these papers, and AMD confirmed that. But it doesn't seem like a lot of people seem to be aware of this. Not a lot of people seem to be talking about how it is partially a transformer model. But anyway, transformers really benefit from FP8 acceleration, or floating point acceleration, that RDNA 4 has that RDNA 3 does not. But these same papers that I was reading about, talking about the hybrid model, each one of them also talked about removing the transformer part of the network and simply relying on the convolutional layers of the network. This paper had a diagram showing the basic structure of their network. It shows the convolutional layers at first, passing data into the transformer block, and that heading into a detail augmentation block. But then they also studied the effects of removing this part of the model. And when looking at this overview of the network, you can see that what that would mean is something like this, where it's simply skipping over this part, the lightweight transformer part, because this part itself is just augmenting the data, refining the data coming from the convolutional layers, the first set of convolutional layers. But what I learned that was really interesting, because I thought that that would just make it like DLSS 2 or XeSS or even PSSR. But what I learned is that when they did that in this study, they still kept the data augmentation block, which is still a transformer-inspired mechanism for implementing what they call attention into the model. But fundamentally, it's still a convolutional mechanism. It's a convolutional layer, from my understanding, but the main purpose of it is to reduce the over-smoothing, which is possible. But the main purpose of it is to reduce the over-smoothing of textures and edges. You may call that blurring. That might come from traditional convolutional neural networks. So the full-blown regular FSR 4 would look like this. It would have the lightweight transformer block and the data augmentation block, all of this together. But then later on down the line, AMD could release a cut-down non-hybrid model that I'm calling FSR 4 Lite, and it would not, because it would not require the FP8 acceleration of RDNA 4, and it would be able to run on the AI accelerators of RDNA 3, which people don't talk about a lot, that RDNA 3 has AI accelerators. A lot of people seem to imply RDNA 4 is the first architecture with AI accelerators for AMD. They just didn't support all the data types that RDNA 4 does now, which is bringing RDNA 4 closer in line with NVIDIA's support for different data types on their tensor cores. But yeah, based on these papers, it seems like a very doable change and something that wouldn't be terribly hard for them to just forego this fancy transformer part of the model, but still maintain, potentially, based on these papers, a still fancy data augmentation block, which still is a result of advancements in machine learning in recent years since transformer models. But yeah, the implications of removing the transformer block while retaining the DAB block, the detail attention block. I might have called it augmentation before. The detail attention block. The implications of removing the transformer block may lead to potentially artifacts like aliasing, because it doesn't have the global context of the entire image that the transformer block was providing, and it might lead to over sharpening if the DAB block is potentially enhancing details too much. which is its purpose. In fact, let's talk about the DAB block a little bit. In the paper, they talk about how it's an attention mechanism. They say that it's indispensable for producing highly detailed visuals. And the DAB is kind of just like a layer that sits on top of the basic feature extraction layers that are extracting things like, here's an edge, here's a line, here's a specific pattern in this image. My understanding is the DAB takes a higher level understanding of those details to create ideas like, this is a fence, and then further understands how to enhance the output. In more like human terms, it's kind of like the first convolutional layers. The first convolutional layers are extracting things like, there are some trees. If you're looking at an image of a mountain, it might extract details like, there's a tree, there's some snow, there's some rocks, and there's some clouds in this image. Without the further layers afterwards, it would never understand that it's a picture of a mountain. And that understanding of what a mountain is leads to the model being able to upscale it more accurately and in a way that aligns with our expectations of how things should look. And yeah, they also talked about this in this paper too. They actually talked about a few different ways that they pruned or did ablation on the model, which, if you want to be crude, you could maybe think of it like lobotomizing the model. But that's kind of a negative way to look at it. In this way, you could call it pruning the model to make it more efficient. And they tried doing that in a few different ways in the second study that I'm looking at. And one of them was by removing the transformer style part of the network. And they found that it had a significant effect on the quality of the output. It doesn't seem like it was so significant that it made the model bad or unimpressive. And the reason they conducted this test was mostly to emphasize the importance of the transformer layer. But yeah, I think it's very possible for AMD to do something very similar to this, considering the architecture of this paper's network seems very similar to how FSR 4 could be. I mean, they're both CNN transformer hybrid models. And I would not be surprised if AMD's research for FSR 4 was based on this paper, or papers just like it, considering they were released in 2022 and 2023. In fact, to go on a little tangent, my assumption is that the initial version of FSR 4 was simply a CNN style network, a CNN model, just like DLSS 2 and XeSS. But then as time went on, AMD maybe got inside info that NVIDIA was working on a transformer model, and they realized, or just that these papers came out and they realized that they could greatly improve their network. So I think they already have both versions of the network. I think they already have their full-blown RDNA 4 FSR 4 model that they're releasing first because it's better. They want people to have a positive opinion of FSR 4, and they want people to have a reason to buy their new RDNA 4 cards. But that once that happens, they will release a cut-down version of FSR 4 that's designed to run on RDNA 3 GPUs and RDNA 3.5 GPUs, obviously, and they'll get a lot of good press for it. So this is the most advantageous thing for AMD to do, which I think it makes sense. And that there's some precedent for doing this with Intel releasing XeSS XMX path for their Arc GPUs and DP4A path for other GPUs. And while that's not exactly the same thing, it's kind of a similar idea of same upscaler, same implementation, different configurations for different architectures. And I think if AMD really wanted to be crazy, they might even allow RDNA 2 to run it somehow. But RDNA 2 doesn't have AI accelerators, so I wouldn't expect that. It would probably take a significant amount of performance from the game. But I would still be really interested in that if they could have the FSR 4 Lite model, even if it doesn't improve performance for the game at all while using upscaling. Even if it doesn't improve performance, to still see it running on RDNA 2, that would be really interesting. Maybe that's a lot of work or not technically possible. It seems like it would be possible to me, just without any hardware acceleration. But yeah, that's my theory. That's what I think is going to happen. RDNA 3 owners, RX 7900 and 7800 owners, do not fret, do not fear, because AMD is not going to announce that FSR 4 will run on older GPUs soon, because it is in their best interests to not announce that yet. But I'm pretty confident that they have versions of FSR 4 that run on RDNA 3, or at least have experimented with removing the transformer block from the architecture and evaluated the possibility of running it on RDNA 3. So yeah, my assumption is they have a few different versions of the model. They found which one worked well. They're releasing that hybrid model for RDNA 4. It's going to get good press, and then they'll get more good press later on for porting a cut down version of that model to RDNA 3, but that they're not going to announce doing that yet because they need to keep up the high-end perception of FSR 4 and the perception that RDNA 4 is significantly better at AI in some way, which it is, but they make it seem like it's a giant leap if it's able to run this AI model and RDNA 3 is not, and then they'll get a lot of good press for being the good guy with AMD Fine Wine backporting it to RDNA 3. So yeah, let me know what you guys think of that in the description. I haven't heard anyone else talking about that possibility, but yeah, all three of these papers discuss doing something very similar. It's called ablation. If you want to learn more about doing lobotomies on neural networks, you could look up ablation. I thought that was kind of interesting. Sometimes people call it obliteration, but yeah. Anyway, I'm still working on my next video about neural supersampling and denoising, AMD's ray reconstruction technology, so that should come out in a few days. I've got work the next few days, so I gotta not spend time researching graphics technology for a few hours. Ugh, it sounds horrible. But yeah, once I'm able to get back home, make that video about ray reconstruction and neural rendering. Also, I want to do a video about neural rendering on AMD's GPUs. And yeah, if people really like these videos, then I will for sure keep making them. I am so glad the last one got a lot of positive feedback. So yeah, if that keeps happening, I'll for sure keep making these videos. So I'll see you guys later. Goodbye. Peace.